Alexandra Tiñana, and I'm going to teach you how to graph and solve a conic section ellipse with 4 different conditions. But to start it all up, let me give you some short information about what calculus, conic sections, and ellipse are. So are you ready? Let's get started!
So what is calculus? Calculus is said to be the study of how things change. Calculus can also be coded with the change in speed and the different models of architecture. But the big question is, how can calculus make our lives this complicated? Well, according to what is calculus and why do we study it, it provides a way for us to construct relatively simple quantitative models of change and to deduce the consequences. So now we're done with calculus, let's now move on to the topic of conic sections. Today I'll tell you what conic sections are and the 4 different types of conic sections. First of all, conic sections are plane curves that can be formed by cutting a double right circular cone with a plane at various angles, as you can see below. Now let's move on to the 4 types of conic sections. The first type is the circle, second is the ellipse, third is the parabola, and lastly is the hyperbola. Now we're also done with discussing the conic sections. Let's now focus on ellipses. What are ellipses? Today I'll discuss to you the meaning of ellipse and different properties of ellipse. Ellipses are known to be the set of points in a plane such that the sum of the distances from each point to 2 fixed points is constant. Next, let's move into the properties of ellipse. Each of the 2 fixed points are called the focus. The line containing the foci intersects the ellipse at point called the vertices. The segment that passes through the focus is the focal chord or lattice rectum and has a length of 2 squared a. The line segment between the vertices is called the major axis, and its midpoint is the center of the ellipse. Lastly, a line perpendicular to the major axis from the center intersects the ellipse at points called the co-vertices, and the line segment between the co-vertices is called the minor axis.
Now we're done discussing what calculus, conic sections, and ellipse are. Let's now move on to solving and graphing an ellipse with 4 different conditions. For the first condition, the givens are foci at 3, -6, and 7, -6, and it has a major axis of 8 units. With this, we can say that our equation has an horizontal ellipse since its x-axis are not the same while its y-axis are the same. The next thing for us to do is find A.
Kept tumbling down in the city that we loved. Gray clouds roll over the
Since we already know that A, or our major axis, is equal to 8, we just divide it by 2. Our A then becomes 4.
Does it almost feel like nothing's changed at all?
We then find for C. We use the formula 2C is equal to the absolute value of x of 1 minus x of 2. We use the coordinates of our foci, which are 3 and 7. With that, we know that C is equal to 2. Since B is unknown, we use the formula a squared is equal to b squared plus c squared. Then we derive it, so then it becomes b squared is equal to a squared minus c squared, wherein a is equal to 4 and c is equal to 2.
Great clouds roll over the hills, bringing darkness from above.
B is then equal to square root of 12. We are nearly done in solving our equation, since we already know that a is equal to 4, b is equal to square root of 12, and the center is located at 5, -6. We then substitute it, so it now becomes the quantity of x minus 5 squared over 16 plus the quantity of y plus 6 squared over 12 is equal to 1. Now there you have our standard equation.
Oh, where do we begin?
For our second equation, the given are foci at 3, 0, negative 1, 0, and the vertices at 4, 0, negative 2, 0. Once again, we can say that our ellipse is horizontal since the y-axis are the same.
Down in the city that we loved, gray clouds roll over.
To find the center, we use the midpoint formula. M is equal to x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. We use the coordinates of our foci, which are 3, negative 1, 0.
Close your eyes. Does it almost feel like you've been here before? How am I gonna be the optimist about this?
With that, we can say that our center is located at 1, 0. Once again, we have to look for C. We use the formula 2C is equal to the absolute value of x sub 1 minus x sub 2. We then can say that C is equal to 2. Now we have to look for the value of A. We use the formula 2A is equal to the absolute value of x sub 1 minus x sub 2, and we use the coordinates of our vertices, which are 4 and negative 2.
My life is kinda boring. Need something that I can confess. Till on my sleeves I
Now, we can then say that A is equal to 3. Now that we know that A is equal to 3 and C is equal to 2, we once again use the formula A squared is equal to B squared plus C squared. Then we derive it to find B squared. B squared is then equal to A squared minus C squared, wherein B squared is equal to 3 squared minus 2 squared.
got no shame.
So then B is equal to square root of 5.
Blame. Just don't let me disappear. I'ma tell you.
Now, once again, we are nearly done with our equation, wherein A is equal to 3, B is equal to square root of 5, and our center is located at 1, 0. We can then say that the standard equation of our ellipse is the quantity of x minus 1 squared over 9 plus y squared. For our third equation, the given are center located at 0, 0, its vertex at 0, negative 5, and its point located at negative. Since our center is located at 0, 0, and our vertex is located at 0, negative 5, with our given and the standard equation of an ellipse, which is x squared over b squared plus y squared over a squared is equal to 1, we can then substitute the points. Our equation then becomes 4 over b squared plus 16 over 25 is equal to 1. We then use the cross multiplication formula, wherein 16b squared plus 100 is equal to 25b squared. Our equation then becomes x squared over 100 over 9 plus y squared over 25 is equal to 1. We can then simply put 9 beside x squared, and then becomes 9x squared over 100 plus y squared over 25 is equal to 1. And that's our standard equation. Now for our last conditions, the givens are focus at 0, 3, vertex at 0, 4, and its center is located at 0, 0. We can then simply say that RC is equal to 3 and RA is equal to 4. So now, once again, what's missing is B. We then use the formula A squared is equal to B squared plus C squared, then derive it once again, it becomes B squared is equal to A squared minus C squared. Then we substitute.
Now, once again, we are nearly done with our equation wherein a is equal to 4, b is equal to square root of 7, and our center is located at 0, 0. Our standard equation now is x squared over 7 plus y squared over 16 is equal to 1.
So now I'm done discussing to you how you can solve a conic sectional ellipse with 4 different conditions. I hope that you learned a lot from this video, and if you like this video, click the like button down below, and if you've got some comments, suggestions, just comment down below. So thank you very much, and I hope you like this video. Have a great day. Bye-bye.